Alright, what we're looking at today is the law of cosines to get the other remaining cases. We could use sines when we had side angle, we had side angle, side angle, or angle side. Now we're going to look at two new cases, side, and side angle side. Now it's going to look complicated using one of these three formulas that we have, or these three equations, but really I can say you can use just one and get the other ones based off of it. What I mean is, whatever side here I have by itself, that's the angle I'm going to use. I'm using one and only one angle. So then the other ones, B in this case and C, end up coming up in the other places in the formula. So whatever angle you need to find, that's the side that's by itself. And I'll show you what I mean here in this first example, where we have that, in this case, a side angle side problem. What angle do I have on its own? Well, that's angle C. So because of that, I'm going to need to find side C, which means I'm going to use, if we go back to our first one, means I'm going to be using this third equation down here that has C by itself with C as, big C as the angle. So that means I'm going to have C squared equal to A squared plus B squared minus 2AB cosine of C. Now all we're going to do here is just plug in for what we know. We know A is 6, we know B is 9, 2 times 6 times 9 times cosine of C. I'm going to end up getting, when I simplify all that C squared is equal to, this will be 117 minus 76.37. C squared is equal to 40.63. And that means that C ends up being 6.37 for your length. So now what that means is if I look at this triangle, I now know that C is 6.37. Now I have an angle comparison, angle C and side C. So from this point forward in the problem, I can go back to the law of sines. I can go back and set up that sine of C over C equals sine of A over A, that sort of thing. So what do I know? I know sine of 45, that's angle C, over sine C, 6.37, must equal sine of, let's say, let's find big A, over 6. When I cross multiply and divide, I should get that sine of A is equal to 0.66, and that means that when I take the inverse sine of both sides, remember I want to do inverse sine to get that A by itself, it means I'm going to get that A is going to equal about 41.76 degrees. So then now I have two angles. I can find the last angle, which is angle B, and in this case, angle B, whatever's left over from 180 is 93.24 degrees. I'll give you another example for you to try on your own if you would like. Go ahead and try to solve this triangle, and I will give you the answers for you to check as you go. You should end up with B is equal to 19.6. You would end up getting that angle A is equal to 38.9, and angle C equals 103.1 degrees. So give that one a try. In this case, you have angle B, so that's the one you want to have out front. Side B equals B squared, A squared plus C squared minus 2AC cosine of B. That's how you should set it out. See if you can get those answers. Now, the other kind we can do is some side problems, like we have here in this example. Side. Now, whenever we said in law of sines that we could end up getting an obtuse angle with that ambiguous case, and the calculator wasn't smart enough for us. So we want to look, and we don't want to get an obtuse angle because things can get really hairy. So what I'm going to say is, which of these angles could be obtuse? If it's any of them, it would be angle B, because that's the biggest angle, because it's across from the biggest side. So we don't want to look at B. We want to look elsewhere. Let's look at the smallest one. That's what we want to find first, is the smallest angle. So if we want to find A, it means I'm going to do again, A squared equals B squared plus C squared minus 2BC cosine of A. Well, cosine of A is what we're going to want in the end. So what I'm going to do is plug in everything else that I know and go from there. So A squared equals B is 19 squared, C is 14 squared, 19 times 14 cosine of A. What I'm going going to do from here is just try to simplify the best that I can. So when I do that, I should end up doing some subtraction here. I need to subtract 19 squared, subtract 14 squared. 14 squared from both sides, so I got to do it over here as well. When I do that, I'll be left over here with negative 435, I believe it is. And on the right-hand side, I will double check to make sure my numbers are correct. 2 times 19 times 14 should give me negative 532 cosine of A. I'm going to check my numbers on the right. Now I don't trust myself. 8 squared minus 19 squared minus 14 squared should give me negative, see, told you I didn't trust myself, negative 493. Okay, so now I need to get, again, cosine of A by itself. So to do that, I'm going to divide by negative 532 both sides. Divide by negative 532. I should be left with, then, divided by 532. When I do that, I should get 0.927 is equal to cosine of A. So again, like we did in the previous problems, to get A by itself, I need to take the inverse cosine of both sides. Make sure you're doing cosine and not sine for this one. And when you do, you should get an answer of, if I get the right side out, you should get an answer for angle A to be 22.07 degrees for that one. And again, now you have a side and angle combination, because you're going to have angle A now, we'll say 22.1 degrees. From here, now you can just do law of sines again. So sine of 22.1 over 8 will equal sine of 8c over 14. You would cross multiply and divide, and you should get that c is equal to 41.14 degrees. And then it's triangle sum theorem from there, which means that b should equal 116.8 degrees as your final answer there. Alright? Again, I'll give you another one for you to try on your own if you would like, to check and see how you're doing. The angle I want to find first is angle A, because that's going to be the smallest yet again. In this one, you should get A equals 34.2 degrees. Angle B is about 66.0 degrees, and C should be 79.8 degrees. See if you can do that. Again, since we're looking for side A, or angle A, we're going to have side A by itself. A squared equals B squared plus C squared minus 2BC cosine big A. Also, I should mention, if you prefer to do it a different way, instead of plugging in and then rearranging, I can rearrange first. I can subtract B squared, subtract C squared from the beginning. B squared, C squared. When I do that, I'm going to have A squared minus B squared minus C squared equals negative 2BC cosine of A. To get cosine of A by itself, I will divide by negative 2BC, which means I got to do that over here as well, negative 2BC. And that's going to leave me with that cosine of A is going to equal, this negative is going to distribute to everything up here. So B squared plus C squared minus A squared all over 2BC. If you want to do that first and then plug in, you're more than welcome to go that route as well. It's whatever works better for you. And that's the law of cosine.